CCSP exam practice questions. Domain 2, Cloud Data Security. Part 4. Question 1. A security architect is explaining to stakeholders why the Web of Trust model was never widely adopted outside technical communities. Which of the following best describes the main limitation of the Web of Trust model? A. It requires certificate authorities to validate identities. B. It only works with asymmetric encryption algorithms. C. The decentralized approach makes it difficult to manage. D. It cannot support digital signatures for authentication. Correct answer. C. Explanation. The Web of Trust model, introduced by Phil Zimmermann with PGP encryption software, faced several challenges that limited its adoption. The primary limitation was its decentralized nature, which made it difficult to manage effectively. The model relies on peer-to-peer trust relationships where users sign each other's public keys, creating a network of trust relationships. While this approach eliminates the need for centralized authorities, it creates significant management challenges, requires high technical knowledge from users, and presents a high barrier to entry for new participants. This complexity in management is why PKI, with its centralized certificate authorities, became the preferred model for most organizations and general users. Question 2. A company is implementing digital signatures for document authentication. Which statement accurately describes how digital signatures provide non-repudiation? A. The sender's private key is used to encrypt the entire message. B. The recipient's public key encrypts the message digest. C. The hash function creates a unique identifier for the message. D. The sender's private key encrypts the message digest. Correct answer. D. Explanation. Digital signatures provide non-repudiation by having the sender encrypt the message digest, hash, with their private key. This process is crucial because only the sender possesses their private key, making it impossible for them to deny creating the signature later. When the recipient uses the sender's public key to decrypt the signature and gets a matching message digest, it proves conclusively that the sender, the owner of the private key, created the signature. The other options either describe incorrect processes or elements that don't specifically provide non-repudiation. Using the sender's private key to encrypt the message digest, rather than the entire message, is more efficient and provides the same security benefits. Question 3. What is the primary reason for using the OCSP protocol instead of CRLs for certificate validation? A. OCSP provides stronger encryption for certificate data. B. OCSP reduces network bandwidth usage and latency. C. OCSP supports more certificate authorities. D. OCSP allows longer certificate validity periods. Correct answer, B. Explanation. The Online Certificate Status Protocol, OCSP, was developed to address the inefficiencies of certificate revocation lists, CRLs. The primary advantage of OCSP is that it reduces network bandwidth usage and provides faster response times compared to CRLs. With CRLs, users must download entire lists of revoked certificates periodically, which becomes increasingly inefficient as the lists grow larger. OCSP, on the other hand, uses an interactive approach where users can query the certificate authority about the status of a specific certificate and receive a simple yes/no response. This targeted approach significantly reduces network bandwidth consumption and provides real-time certificate status information. Question 4. Which security property of hash functions is compromised when two different inputs produce the same hash value? A. Encryption strength. B. Message integrity. C. Collision resistance. D. Key length security. Correct answer, C. Explanation. When two different inputs produce the same hash value, This compromises the collision resistance property of the hash function. Collision resistance is a critical security property that ensures a hash function produces unique outputs for different inputs. When this property is compromised, it means the hash function has failed to maintain its uniqueness requirement, making it possible to find two different inputs that generate the same hash output. This vulnerability can be exploited to forge digital signatures and certificates, as an attacker could substitute one input for another while maintaining the same hash value. This is why algorithms like MD5 and SHA-1 are no longer considered secure after collision vulnerabilities were discovered. Question 5. When verifying a digital signature, what action must be performed first by the recipient? A. Decrypt the digital signature with the sender's public key. B. Calculate the hash of the received message. C. Verify the certificate authority's signature. D. Encrypt the message with the sender's public key. Correct answer, B. Explanation. When verifying a digital signature, the recipient must first calculate the hash of the received message using the same hash function that the sender used. This is the first step because the recipient needs to compare this newly calculated hash with the decrypted signature to verify the message's integrity and authenticity. After calculating the hash, the recipient then decrypts the digital signature using the sender's public key to obtain the original hash value. If both hash values match, it confirms that the message hasn't been altered and was signed by the owner of the private key. This process is fundamental to the digital signature verification workflow and ensures both message integrity and sender authentication. Question 6. Which element of a digital certificate identifies additional domain names that are protected by the same certificate? A. Common name, CN. B. Subject alternative name, SAN. C. Distinguished name, DN. D. Certificate serial number. Correct answer, B. Explanation. The subject alternative name, SEN, is the certificate attribute that identifies additional domain names protected by the same certificate, while the common name, CN, specifies the primary identity secured by the certificate. The SAN extension allows a single certificate to protect multiple domain names or identities. This is particularly useful for organizations that operate multiple domains or subdomains and want to secure them with a single certificate. For example, a certificate might have a CN of www.example.com, but include SANs for example.com, mail.example.com, and other related domains. This capability makes certificate management more efficient and cost-effective for organizations managing multiple domains. Question 7. A security team is evaluating hash functions for use in their PKI implementation. What is the main reason SHA-3 is considered more secure than SHA-2? A. SHA-3 produces longer hash values. B. SHA-3 uses different mathematical techniques. C. SHA-3 processes data more quickly. D. SHA-3 has government certification. Correct answer, B. Explanation. SHA-3 is considered more secure than SHA-2, primarily because it uses completely different mathematical techniques. While SHA-2 uses similar mathematical approaches to SHA-1 and MD5, which have known vulnerabilities, SHA-3, KEKAK, employs an entirely different mathematical foundation. This different approach means that even if vulnerabilities are found in the mathematical basis of SHA-2, they would not affect SHA-3. The distinction is important because it provides algorithmic diversity in cryptographic systems, reducing the risk that a single mathematical breakthrough could compromise multiple hash functions simultaneously. Question 8. During the certificate creation process, what is the main purpose of a certificate signing request, CSR? A. To validate the certificate authority's identity. B. To provide the public key and identity information to the CA. C. To generate the private-public key pair. D. To establish the certificate's validity period. Correct answer. B. Explanation. The main purpose of a certificate signing request, CSR, is to provide the public key and identity information to the certificate authority, CA. The CSR contains essential information that will be included in the final certificate, including the requester's public key and identifying information such as name, organization, and domain name. This information allows the CA to verify the requester's identity and create a certificate that binds the public key to the verified identity. The CSR is generated after the key pair is created and before the CA issues the certificate, serving as a standardized way to submit the necessary information for certificate issuance. Question 9. What is the primary reason that good hash functions must be collision-resistant for use in digital signatures? A. To prevent unauthorized decryption of messages. B. To ensure proper key distribution. C. To prevent signature forgery. D. To maintain message confidentiality. Correct answer, C. Explanation. Collision resistance is crucial for hash functions used in digital signatures, primarily to prevent signature forgery. If a hash function is not collision resistant, meaning two different inputs can produce the same hash value, an attacker could potentially create a fraudulent document that generates the same hash as a legitimate document. Since digital signatures work by signing the hash of a document, a hash collision would allow an attacker to substitute the fraudulent document while maintaining a valid signature. This would undermine the integrity and non-repudiation properties of digital signatures, making them unreliable for authentication and verification purposes. Question 10. A company is implementing HMAC for message authentication. Which of the following best describes how HMAC provides message integrity? A. It uses public key encryption to secure the message. B. It combines a hash function with a shared secret key. C. It relies on digital certificates for verification. D. It encrypts the entire message content. Correct answer, B. Explanation. HMAC, hash-based message authentication code, provides message integrity by combining a hash function with a shared secret key. This combination creates a mechanism where both the sender and receiver use the same secret key, along with a hash function to create and verify a message authentication code. The secret key ensures that only parties who possess the key can create or verify the HMAC value, while the hash function ensures that any changes to the message will result in a different HMAC value. This makes HMAC an effective tool for verifying both message integrity and authenticity, as an attacker without the secret key cannot generate a valid HMAC value. Question 11. In a PKI environment, what is the primary purpose of the registration authority, RA? A. To generate and store private keys. B. To validate certificate requester identities. C. To issue certificate revocation lists. D. To create digital signatures. Correct answer, B. Explanation. The primary purpose of a registration authority, RA, in a PKI environment is to validate the identities of certificate requesters. The RA acts as a trusted third party that performs the crucial function of verifying that individuals or organizations requesting certificates are who they claim to be. This validation process is essential to maintaining the trust model of PKI, as it ensures that certificates are only issued to properly authenticated entities. While the certificate authority, CA, actually issues the certificate, the RA's role in identity verification is fundamental to the security and reliability of the entire PKI system. Question 12. Which statement accurately describes the relationship between a hash value's length and the input data size? A. Hash value length varies based on input size. B. Hash value length increases with input size. C. Hash value length remains constant regardless of input size. D. Hash value length decreases with input size. Correct answer, C. Explanation. A fundamental characteristic of cryptographic hash functions is that they produce a fixed-length output regardless of the input size. This means whether you hash a single word or an entire book, the resulting hash value will have the same length. This property is essential for hash functions' practical use in digital signatures and other cryptographic applications, as it provides a consistent and predictable output size that can be efficiently processed and stored. For example, SHA-256 always produces a 256-bit hash value, regardless of whether the input is 1 byte or 1 gigabyte of data.